Hello, you're viewing the OpenRMC sub-project of the OCP hardware management project. This presentation is being done live, so you should know that. My name is John Leung, and a principal engineer at Intel. Han and I are co-project leads of the OpenRMC project. Han is a senior architect at Inspur. Today, we're going to provide an overview and a status update for OpenRMC. This is the overall agenda. We will start with an overview of the goals of the OpenRMC project when it started in 2018. We will then drill down on the Northbound interface and describe that would have to exist on an OpenRMC compliant platform. We will explain the new strategy that the OpenRMC project adopted at the end of 2019. And then we will present an upcoming contribution based on that new strategy. We also talk about the strategy embodied in the OpenRMC design requirement specification, which came out of the replan. Starting at the meeting started at the end of 2018. There was the major firmwares on the OCP platform was Open System Firmware, which is being dealt with as a OCP incubation committee project, and OpenRMC, which is our Linux Foundation open source project. And those are the two major firmware which exist on a platform. The next layer of firmware is the rack manager. And the OCP wanted to be a first mover and understand that eventually that firmware would need to be constructed in order to build a fully blown OCP platform at the rack level. So and learning from the OpenRMC history, where OpenRMC was released by Facebook about 5 years ago, and it had as open source, and it had fractured over that time. And so by the time Intel wanted to add Redfish on top of OpenRMC, it found basically six repositories. It spent quite a bit of time bringing those repositories back together as a single unified repository, created it as a project under the Open System Foundation for governance, and then as it proceeded about 2 years ago, putting Redfish on top of it and releasing it as a unified source that could now run on top of a OCP platform. So OCP did not want to follow that route and actually wanted to try and be the instigator of rack management firmware. And so it started this project to kind of bring everything together before the industry had a chance to fracture itself. So what the goals of the actual project was to specify a Northbound interface for the rack manager. This interface will be specified in Redfish. It has been approved at 1.0 level and will soon be submitted into the incubation committee. Based on that, it would also begin to ask for contributions of RMC firmware. During that time of 2019, it received 3 contributions. And so what it wanted to do was basically in the near future, not only have software contributions, but also have that software bundled with a piece of hardware. Because having software is good, it's not sufficient for us to build a actual rack management platform. On the south side of the rack manager, we would have various interfaces to instantiate how you actually talk to particular platforms. One of those could be Redfish itself. And that particular southbound interface would align with the profiles for basic manageability that we have at OCP. So this is a drill down of the Northbound interface. So the Northbound interface is specified as a Redfish interface. Redfish is an interface focused on manageability. It is internationally recognized, and it's a RESTful interface for managing platforms. What it basically does is it reduces manageability to a URI and a JSON message. So the specification for Redfish is exactly what that interaction is across HTTP, and what paths are for all the resources that can be managed, and then a specification called the schema of exactly what type of messages and information you can get back from those particular resources. So that describes the entire space of all the things that you can manage. What Redfish also has is the concept of a profile. So a profile specifies a subset of Redfish which can be instantiated or required to be implemented. So OCP saw that and basically took the goal of specifying a OCP profile for various OCP platforms. The baseline profile is already published and available. The OpenRMC project chose to take the Redfish implementation and define the OpenRMC profile, which defines the resources and the properties within resource which had to be implemented in order to conform to a OpenRMC design. As you can see on the right-hand side, the DMTF Redfish forum also created a Redfish interop validator, and its goal is actually on the backside of it consumes anybody's profile file, reads it, and then auto-generates tests and runs it against a conformant implementation. So in this way, we have a full chain of OCP specifying a profile that needs to be met, and then testing the profile on the back end once we have an implementation to see if it in fact actually conforms to the profile that has been specified. So at the end of 2019, we had a strategy change. We basically, on the the left-hand side is the original vision and strategy, and on the right-hand side is the revision that we modified. The original goal was for our vendors to contribute the RMC source, that we would go ahead and we got 3 sources contributed, and out of those sources we would the project would choose a set of sources to use to move forward with and unify them as a single OpenRMC source. That turned out to be very problematic because most companies are willing to submit their source, but they're less willing to go work on a unified source that would basically replicate what they already had done. So the modified version of the vision was to abandon the goal of a single OpenRMC source and go back to the original intent of OCP, which is we would like all the binaries on a platform, all the firmware on a platform, to actually be contributed as source code and not binary images. So the current OCP guidelines is that you could contribute things in binary form. And so to do that, we basically said we would retain the RMC source repository, and we use that to host the source code for our contributions of OpenRMC hardware. So that's exactly how we modified the spec. So the spec now talks about the Northbound interface. It basically reflects what's in the profile, but in a more readable fashion, and then it does a reference to the schema file itself and the profile for OpenRMC. Southbound interfaces can be supported. It can be one or more southbound interfaces which connect to the RMC, to the management node. And there was at least one of those interfaces needs to conform to the reference specification in the baseline profile. So that if you're managing OCP platforms which are exposing reference as a manageability, you should at least be able to manage them from the rack manager itself. And then lastly is the most important statement, which is the bundling concept of contributing the firmware in source form as part of the OCP design package. So leveraging on top of the fact that OCP accepts design packages of hardware, generally the statement within manageability is that you deliver the binary images. In this particular case, for an OpenRMC platform, you would deliver the source code, and that would all be placed in the repository. We thought about referencing the company's repository, but the OCP repository allows a more persistent place which doesn't move, so we would just place that firmware source there. Okay. So from 2020 on out, that's what we're looking for is platforms, contributions or bundled contributions. And so with that, we have our first contribution, which is from Inspur, and Han is on the line to go talk to his slide.
Okay, thank you, John. So I would like to talk about a little bit about Inspur bundle solution. So Inspur has contributed both firmware and hardware bundle contributions. So on the wiki, we have the source code and also the software architecture. So the hardware architecture also be presented. You can find the information on the OpenRMC wiki. So the software bundle solution is on top of OpenRMC, and right now is supporting 1+1 redundant RMC. You can look at the right-hand side. So basically, we can have two RMC have interconnection, and each one can stand alone work as an OpenRMC to connect to different nodes. And the hardware and the software bundle solution, we have a demo at OCP Experience Center. So right now it can support multiple language, but the one in the demo center is right now supporting Mandarin and English. You can go there and look at the demo. And I think the coming efforts is all the implementation of the OpenRMC Northbound API Spec v1.0. All the implementation will conform this new spec, and all the profile execution is being performed. So once all this is finished and pass all the validator testing, so the new package will be contributed as well. So that's pretty much about it for firmware, hardware, and bundle contributions. So I would like to give back to John. Thank you.
Okay, with the call to action, of course, with Inspur as contribution, we would also like further contributions of RMC bundle designs using the normal open OCP process. If you can use the profile is available for use at the Open Compute GitHub. And you can also, there's a link there for the validator itself, which is on the DMTF site. You can get additional information on our wiki, and our mail list has been up for a while for any open discussion. So at this point, I know we only have about 30 seconds, so are there any questions that we can answer? Gunnar, I know you've already noted that you're getting a 404. I'll have to go fix that. It should be open. Okay, with that, I think our 15 minutes are up, and so I thank you all for attending and listening to this conference. Thank you.